Hi, this is Chris from the Flat Earth Reality Channel. I'd like to thank you for dropping by and checking out this video. This is the second installment of the Flat Earth Reality Q&A sessions, and this video features questions 6 through 10. Question 6. Storms. Hurricanes typically rotate counterclockwise in the northern hemisphere, and typhoons typically rotate clockwise in the southern hemisphere. Well, on the flat Earth model, the Sun and Moon's path is centered around the equator. The Sun moves in a circular pattern above the Earth every day, and it does so in a spiraling in and out pattern between the tropics to create the seasons. The motion of the oceans goes one way north of the equator and the other way south of the equator, supposedly. I theorize that the Sun and Moon's path separates the waters and causes them to flow differently, or maybe it's some sort of magnetic effect. And as your question states, typically they rotate one way only. There are times when this doesn't happen. I've heard of reports at rare times when hurricanes and typhoons spin the wrong way, which on its own should discount the heliocentric explanation of the Coriolis effect. Question 7. The seasons. It is summertime in the southern hemisphere when it is winter in the northern hemisphere and vice versa. The sun diagram I've seen doesn't allow the sun extra time over the southern hemisphere. That's why it's warmer in the summer, owing to the tilt of the Earth towards or away from the sun. The sun is up longer and the rays are more direct in the summer, heating up the surface longer and more directly. This is not accounted for on the flat Earth map. Explain how this happens. To explain some of what's going on, I'll talk a while and show a clip from Rob Skiba's video on seasons, using stellarium data overlaid on an azimuthal equidistant or flat Earth map. In my opinion, it's an amazing video. He's a Christian and a researcher and a video maker who heard about their flat Earth and decided to look into it and see if it was true or not. He wasn't even a confirmed flat earther at the time of the video you're watching, although I'm pretty sure he is now. He does some of the best work on YouTube for flat earth research, and I highly suggest watching his videos on testing the globe. He went to stellarium, pointed the view straight up, and recorded the Sun and Moon's path for a year. Then he overlaid the data on a flat earth map, and it shows pretty much exactly what the basic flat earth model shows. It's uncanny, isn't it? I think this clip is stunning. There's a link below for anyone that wants to watch the whole thing, which I highly suggest doing. Now, the seasons have been explained on YouTube by flat earthers for some time, and saying we don't have an answer or a model is disingenuous or laziness on the asker's part at best. Plus, the flat earth exploration by masses is fairly new, and we've just got started on all these topics. So as time goes on, we'll have more and more answers for why things work just the way they do. Now, I admit that some of those answers today may lack explaining all of the facts. Many others, like myself, have their own interpretations of what's going on based off of the flat earth model because it's the closest thing that we have right now. The heliocentric model lacks much more than the possibly slightly flawed flat earth model for seasons, at least from what I can tell. And the videos like the one Rob Skiba made are a great help in getting us to the next level of understanding. You might not agree with the concept, but it's laid out for you to understand easy enough. And you can no longer say that flat earthers can't explain seasons. Now, we might not be able to explain it 100% yet, but just give it time. It's not going to take long at all. And I welcome anybody's opinion on the matter. All they have to do is post in the comment section. Question 8. Polaris. Currently, the Earth's axis points more or less directly at Polaris, the pole star in the northern hemisphere. At the pole star, Polaris is directly overhead. When you travel south, Polaris gets lower and lower to the horizon until finally it disappears. It does not appear at all above the horizon for most southern observers. Explain. Well, in the flat Earth model, there's only one sky and one set of stars. They rotate around us once a day. Polaris is the only pole star. Everything rotates around it. You cannot see the whole sky at one time from Earth, even on the flat Earth model, no matter where you stand. Our sight has limits due to atmospheric conditions, perspective, and the vanishing point. If we stand north of the equator and look up, we see the constellations and stars directly overhead. We also see some of the remainder of the stars if we look farther north or south. The opposite is true if we were in the south. They'd see the stars directly overhead of them, but only some of the ones off in the distance as they looked either farther south or north of their position. We just can't see all the sky at once. Our vision has limits due to atmospheric conditions, perspective, and the vanishing point, and the way our eyes collect light. Think of a plane flying from one coast to the other, maintaining its altitude at 25,000 feet. Let's say we, as the ground-based observers, are in the middle of the country. We'd see the plane come into view at the horizon, but from an almost infinitely small point, eventually becoming something that we can distinguish as a plane. It would be low to the ground, because from our vantage point it would be at eye level where the horizon is. So the plane comes into view at eye level, on the horizon, not way up in the sky. It's literally at your own eye's level, around, 5-6 feet for most people? But we know the plane is really cruising at 25,000 feet high, not 6 feet high. The plane will gain in apparent size and apparent altitude or height in the sky, the closer that it gets to us. This again is perspective at work. The plane looks as big as it can and as high up as it can when it's directly overhead of our hypothetical central location. And then the whole pattern happens again, but in reverse as the plane moves farther away from us. But the whole time, we know that the plane did not change in size or get any higher or lower in the air. It's all a matter of perspective. Your eyes build the horizon by making the ground seem to rise up to meet your eye level, and at the same time bring the sky down to meet your eye level. Where they converge is the horizon. When an object is coming into our sight from the horizon, like our hypothetical plane or the sun and the moon, it acts like everything else does with perspective and starts off small and at the vanishing point and coming into view and getting closer and apparently larger. The horizon changes depending on the observer's height and altitude, but it will always remain at eye level, something that the heliocentric model just cannot explain. The horizon should drop the higher we go if we were on a sphere, but we're not, so it doesn't, not even from 20 miles up. The stars are not suns incredibly far away. Lack of any stellar parallax shows us that. Things are not the way we are told they are. Simply put, Polaris is too far away from those in the deep southern locations to see it due to perspective, and the horizon and the vanishing points, the same effect that causes the sun and moon to set and rise. The sky and the stars rotate around us at the same speed. The wandering stars, or planets to some, move slightly differently, but still at relatively the same speed like the sun and moon. Star trail effects intrigue me, and I have spent some time looking into them. I'm not prepared to go into detail right now, but I think there's a certain YouTube researcher who's onto something. If I can vet it out, then I'll give him full credit and make a video about it. A point in our favor is the fact that the star trail effect that we see around Polaris is not possible on a sphere, except for at the very North Pole and at the equinoxes. It's the focus of one of my upcoming videos in my new series, Top 10 Proofs Against the Heliocentric Model, so I won't get into detail here, you'll have to wait for the video. Question 9. Constellations. Same as Polaris, the southern hemisphere has different constellations than the northern. On the flat Earth, everybody would see the same constellations all the time. Constellations are also upside down in the southern hemisphere. Orion is standing on his head in Australia. The moon and planets and the sunspots that are visible are all upside down in the southern hemisphere. On a flat Earth, they would look the same everywhere. Well, as my last answer explained, the stars above are rotating around us, around a central point, very near or right at Polaris. One spot. We simply cannot see the entire sky, all the visible stars, at one time from no matter where we are on Earth. So, no matter where we are, some part of that sky will be beyond our ability to see it. Again, the sky is just too big for us to see all of its surface or all of the stars or planets at once, due to perspective. But we are still seeing the same sky. People in the extreme north would see the middle of the sky or stars rotating around Polaris, but couldn't see the end of it or the edges of it. While people in the south or the extreme south could see the sky from closer to the edge looking towards the center of the disk. They can't see all the way to the center, it's just too far away. Perspective takes over and it vanishes into the vanishing point in the horizon. Question 10. Changing size of moon versus sun. The sun and moon both measure about half a degree in arc in the sky. The moon is about 400 times smaller than the sun, but is also 400 times closer. So by coincidence, it exactly covers the sun during a total solar eclipse. The moon's orbit around the Earth is not a perfect circle. Part of the orbit is closer to the Earth than the other. So the moon is visibly measurably bigger for a part of every month when it is closer to the Earth, but the sun is not. The Earth's orbit around the sun is more or less circular, with neither semi-major axis much larger than the other. So the sun is always about the same size. In the flat Earth model, the sun and moon are always the same distance away. There is no explanation for the change of the moon's size. In the sphere model, they had a problem and they wrote down a solution to that problem, as seen if the world was a sphere. Your answer is that the orbit of the moon changes slightly, gets closer to us, and is measurable. If that's a fact, then in the flat Earth model, the same so-called fact would exist, and our model has an explanation too. The orbit of the moon changes slightly, gets closer and farther from us, and it's measurable. I mean, if you guys can do it, we can do it, right? In my opinion, the sun and moon both get closer and farther away from us during their cycles. It's a pattern repeated every year, or for the moon's case, every month, in conjunction with every year. Now, as I mentioned in a previous question, Rob Skiba did some great work on stellarium data, plugging it all into an AE map, and to me, it's confirmation of the flat Earth model for seasons. But that video doesn't show any height increase or decrease with the sun and the moon, or if it does, it's not easily visible. However, admittedly, I have theorized about the sun's path much more than the moon's, and it is the focus of one of my upcoming videos, but right now it's more theory than proof. So I look forward to hearing other people's opinions about this question with respect to the flat Earth model. So if you've got one, leave it in the comments section below. Measuring the sun and moon's size by their arc in the sky shows them to be about 32 nautical miles in diameter and about 3,000 miles high. Now I'll ask you, is it easier to believe that the two are equal in size and relatively on the same plane? Or is it easier to believe the most amazing and incredible coincidence ever of being 400 times smaller and 400 times closer, a quadrillion to 1 chance? I mean, either way, I'd say it's proof of the Creator, wouldn't you? Alright, that does it for this installment of Flat Earth Q&A. Subscribe to my channel to catch the rest of the series as it comes out. Folks, love each other, would you? And remember that God loves you very much, and we'll talk soon.